Hi everyone. In this section, we're going to go through some of the equations that we're going to use with centripetal force. So not necessarily the most exciting little video, but boy, is it packed with a lot of important stuff. For all of these equations, please write them on your formula sheet so you've got them all in one place. And here goes. Centripetal force is a special case of F equals ma. Remember Newton's second law, you've got to have an unbalanced force in order to make an object accelerate. And going in a circle is a form of acceleration. So a special case of this is centripetal force is mass times centripetal acceleration. And that centripetal acceleration is the acceleration towards the middle of the circle. So if I've got an object that is spinning around a circle like this, there's going to be a centripetal force towards the middle of the circle, and the centripetal acceleration is always in the same direction as the unbalanced force. So centripetal acceleration is also going to be towards the middle of the circle. A new equation is this one. Centripetal acceleration is velocity squared divided by r. Now, AC is centripetal acceleration. V is that instantaneous tangential velocity. Remember we talked about if you've got a tire or something going around like this, and it has a velocity at an instant going forward, that's the instantaneous tangential velocity, measured in plain old meters per second. Where is this equation really useful? Let's say you've got an object like a car tire, and it is spinning round and round and round. If you know the radius of rotation, r, and you know the speed, well, what's the instantaneous tangential velocity in a car? It's going to be however many miles per hour are on your car odometer or speedometer. Then you can calculate the rate of acceleration on that vehicle. Now, how do the units play out? Because this is kind of wacky. I've got velocity squared over r. So this is going to be meters squared per second squared divided by radius units meters. What we do always with fractions is invert and multiply. 1 over meters, this one's going to cancel that, and I'll end up with meters per second squared, which is acceleration units. If we take centripetal force is mass times centripetal acceleration and replace centripetal acceleration with this equation, we end up with this version of centripetal force, useful in lots of different situations. Let's talk about velocity in a circle. Let's say I've got an object that's just going in a circular path. And it could be something as simple as the Earth going around the sun, or as complicated as a collection of gears, or maybe a DVD that's spinning. The distance around a circle is called its circumference. So we can replace the velocity as change in displacement over time. So the displacement is 2 pi r, that circumference. And there's a new term, and the term is period. Period is the time it takes an object to go around an orbit or rotation once. And it is usually abbreviated with a capital T, and it's measured in seconds. So a simple velocity in a circle equation is 2 pi r, 2 times pi times the radius of my circle, divided by T, the time to go around once. And I acknowledge and I apologize for the entire universe. This gets confusing because period is a capital T and tension is a capital T. Yeah, sorry. Now, a lot of homework problems are going to ask you to do this, and I want to show you how this unfolds. If I've got velocity in a circle and I've got centripetal acceleration, what happens if I replace velocity with 2 pi r over t? Well, velocity squared is going to be 4, 2 squared, pi squared, r squared, divided by t squared. So all of this is equivalent to velocity squared. And then this is going to be divided by r. I've got another radius down here. This cancels this one, and I end up with centripetal acceleration is 4 pi squared r over t squared. And this is another equation for centripetal acceleration, and it's really handy. Frequency. Frequency, you understand the basic English definition of the word frequency. Frequency is how often. If I asked you, how often do you get paid? Well, you might get paid once a week or once a month or once every 2 weeks. It is something happens per unit of time. There are a number of occurrences per unit time, and that's frequency. We apply the term frequency to lots of situations. We apply it to orbiting or rotational situations. We apply it to waves. We apply it to vibrations. And the units of frequency are whatever we're talking about, revolutions, waves, vibrations, whatever, per unit time. Now, in the MKS system in physics, we tend to stick to time in seconds. So revolutions per second, waves per second, vibrations per second. Here's the challenge. Revolution, waves, and vibrations are not actual units. These things are just descriptive words. And the reason we put those words there are, one, human beings don't like saying per second. What per second? Well, we have to put a descriptor on top. Vibrations per second, revolutions per second. But frequency units are actually per second. Because this is so uncomfortable for us to say, a new unit that is equivalent to 1 per second is called the hertz, abbreviated capital HZ. And hertz for frequency, you're going to see it in things like, this is a diesel engine, and it is going to have, oh, that's not hertz. Here is a radio frequency dial, and the different radio bands are megahertz or kilohertz. Alternating current, AC electricity, is 60 hertz in the United States. That means it alternates up and down 60 times per second. Another place you're going to see frequency units often, you're going to see these, revolutions per minute. And revolutions per minute are handy, but trust me, you're going to have to convert those down into per seconds before you do an awful lot of math with them. There's a relationship between frequency and period. Frequency is 1 over period, and period is 1 over frequency. Frequency in those hertz or per seconds, and period in seconds. So sometimes you're going to get a time in seconds for one oscillation or go around, and frequency, sometimes you're going to get number per unit time. And these two are the inverse of each other. All right, that'll do. Now you are armed with lots of tools. Next up, we're going to use them.